Now, okay, super. Remember the famous 7 steps that we have to apply for solving any problem of the rational function. The first is factory form. In the factory form, pure factorization, the expression at the top, is a monomial. It's impossible to do something. But in this case, it's binomial. A special binomial is the differences of the square. I suppose that so far everyone follow me, no? Now, the second step is y-z. Y-z is when the function is 0, you value is 0. 4 times 0 divided by 0 squared minus 4. So see, the top is 0. I don't care the bottom. The answer is 0, and our intercept is 0, 0, is the origin. When it's the origin, happen que is equal to the x-intercept. But okay, just in case, maybe we have another, no? Okay, you force the function equal to 0 for x over x squared minus 4 equal to 0. In conclusion, this is the top part only equal to 0. Therefore, again, we come back again to the same answer, x equals 0, case d0. Okay, that's a conclusion so far. We have only one intercept is at the point 0, 0. Okay, in this case, both x and y. Okay, the vertical asymptote is the next step. It's super easy because either way, you take the expression at the bottom, remember q and x equals 0. After the factorization, for sure, when you solve this equation, you get the vertical asymptote number, no? Entonces, well, entonces, you set out this equation. It's a quadratic equation. It's incomplete quadratic equation. It's an equation that you can solve easier by square root, and the answer is plus or minus 2. Therefore, we have two vertical asymptotes. Two vertical asymptotes at x equal 2 and at x equal negative 2. Number 5 is the horizontal slant. Horizontal or slant. I want to copy again my expression, 4x divided by x squared minus 4. The degree analysis of the top is 1. Degree of the bottom is 2. When this situation happens, yes, we have, yes. But a special case. And a special case is y equals 0. So in this moment, please don't forget to verify if the curve crosses or not this horizontal asymptote. It's easy. You enforce the equation. 4x over x squared minus 4 equal to 0. And this is exactly the same I did before, because x equals 0. When I try to compute the famous x-intercept. Entonces now, this famous point 0, 0 is x-intercept, y-intercept, and also the famous point in which the curve crosses the horizontal asymptote. Okay, this is an important point. Plot this point is super important. One more information we have and 2 vertical asymptote. Okay. No more asymptote. No. This is land, no. So now definitely 6th step is symmetry. Check the symmetry. Check the symmetry is easy. You make a reflection in our function. And let's see what happens. To make a reflection, remember I copy again one more time my original expression, and you now make a reflection. Reflection is replace x for negative x. We have 4 times negative x divided by negative x squared minus 4. Negative x times 4 is negative 4x divided by x squared, you know, what is exponent even is positive, regardless, the quantity inside the parenthesis is positive or negative, minus 4. Let me manipulate a little bit, only I put negative here in the front, and this is a moment to compare this expression and this expression. And you see, wow, look like similar, except we have a minus here in the front. This is equivalent to say the function after the transformation, we have one negative side like that. And this is a typical odd function. And remember, odd function is a function that its symmetry is like that. Maybe it's, you know, let me use another color. Maybe the function is like that. But and the origin is exactly the same. Odd function. Symmetry with respect to the origin. Or like that, I have no idea. Okay, this is the typical odd function. Okay, finally, well, I try to make all real number line. I plot the point, get 0, 0. 0 here. Well, 0, 0, 0, 0. And also, I discovered that we have two variable acids. And 2 in negative 2. 1, 2, variable acid. In negative 1, 2, another variable acid. So to evaluate, remember, you can take several points. But a smart point, for example, super smart is in 1. So you pick here 1 and plug it in the original equation. This is okay. I pick this because it's in between 0 and 2. I can pick negative 1, yeah, we can. But positive 1, in my opinion, better. So you evaluate in this. When you evaluate this, and you evaluate in 3, that's it. Because I take advantage. Okay, our function is odd function. So you are evaluating 1, the function in 1. I know that the answer is negative f evaluating 1. Or in negative 1, sorry. In negative 1. According to this idea for the symmetry. But you don't need. Well, let's do it. Suppose que you evaluate in 1. Well, it's piece okay, it's probably what? 4 times 1 over 1 squared minus 4. The answer is 4 on the top, negative 3 in the bottom, is a negative 4/3. Okay, you write in decimal. No, it's an approximation because it's a rational number. This is minus 1.33. Repeat. So the point, famous point is 1, negative 1.3. Repeat. I put in decimal because it's easy to see in the rectangular coordinate system. Likewise, the point using the symmetry property. So you replace x for negative x, same value but opposite sign, we get 1.3 positive. The reason is clear because it's odd function. So you only take care the positive part because the negative part is symmetric. But symmetry will respect the origin. That means that this value is 1.3, suppose. And negative 1, and this value is exactly the same but in opposite direction. Super. One more, 3. No, of course, 3. Why not? Evaluate f and 3. This is a 0.7 we are doing this additional point. How many points? In this case, 2 is enough, I suppose. So you want more? It's okay, more. And this one, I did more. It's 4 times 3. Bye. 3 squared minus 4. This is 12. This is 9. Minus 4 is 5. It's 12 over 5. And 12 over 5, we just press it in decimal 2.4. Therefore, we have the point 2.4. This is a 4, guys. 4. You have the point, okay, the point is 3, 2.4, and of course minus 3, minus 2.4. I suppose that we have enough information to do the graph. We have how many points? Wow, we have a lot of points. We have 0.0, remember, we have 4.5 points in total, and we know the numerical asymptote, we have 2 and 2 and the other 2, and we have horizontal asymptote at 0 here. Okay, now I am ready to open Desmos. And when I open Desmos, I can see. Look at that. Boom. Boom. Let me make it zoom. We have, okay, I copy the original function. Range, wow. Let me delete that. Yes. Okay, I copy the original function. Look at that, it's the original function, flashing. We have 2 vertical asymptotes, 1 positive 2, 1 negative 2. We have 1 horizontal at 0. Look at that. And we have different points. In this case, I put 1, 2, 3, 4, 5, 6, 7 points. Wow, too much. Okay, I have no idea how to write the function. And you see clearly now, wow, it's odd function because it's symmetric. We respect the origin. Look, this point and this point. So you are doing a segment line. It's in the opposite direction here. It's symmetric with respect to the origin. And this is exactly the same, this and this, or this and that. Okay? Good or not good? Any question, guys? What part is confused? What part is confused? Today we're doing 2 more examples. Okay, so now I come back to the whiteboard. Okay, ready. Let me erase everything. Good. Very good. Let's move on to example 2. Just wait a second. I want to ask you, do you have questions or not? Everything is clear? The procedure, the methodology to analyze this step by step, 1, 2, 3, 4, 5, 6, 7 steps. Okay? It's clear or not? Okay.
Clear, Professor.
It's clear, good, very good. Okay, let's move on to example 2. Example 2, but I need more participation. I need your help. Suppose the function g. Don't worry if you make a mistake. You are a student. Okay, divided by x squared plus 1. Okay, step number 1, remember, is factor 4. Factor 4. This is super important. Some people try to find what it said, and say, no. The first thing is factorization. It's a factory form. Well, in the top we have trinomial. This trinomial is special, complicated, because the coefficient here is 2. So you multiply this number. I don't care the sign is not important. And it's 5 and 2, because 5 times 2 is 10, and 5 minus 2 is 3. You copy like that. 2x squared minus 5x plus 2x minus 5. Then you split 3, negative 3, and negative 5 and positive 2. Now ready to apply factorization by grouping. The factorization by grouping in between the first couple is x. We have 2x minus 5. The great common factor in the second couple is 1. We have no. It's invisible 1. You want to push, you want no 2x minus 5, but I want to put because I know okay, now this 2x minus 5 is a common factor. They factor out. And inside the next parenthesis x plus 1. Okay, so far, this is the factorization of the top part. The bottom part is x squared plus 1. Wow, look at that. This is the sum of a square. Yeah, I know very well that the sum of a square is impossible. Factorization is prime expression. Therefore, leave it at that. Okay, so in the step, the super fantastic conclusion, and the step 1 is I did the factorization of the top part. 2x minus 5, x plus 1, and I discovered in the denominator we cannot do anything. We can't do anything. Any question? Do you understand very well every step? Do you understand why it's impossible factorization x squared plus 1? Okay, this is the factor form. I did that. I did that. Where is the second step? The second step is y intercept. Y intercept you evaluate the function is 0. Well, I suppose que si evaluate in the original. It doesn't matter. It doesn't matter. Well, the original is easy because you replace mentally x for 0. So in the top, stay alive only negative 5, and the bottom 1, and answer negative 5. Therefore, our famous point again looking for is the point 0, negative 5. Because I enforced x is 0 for finding the y intercept. Likewise, for finding the x intercept, to take the function, you enforce it to be 0. Okay, you know this is equivalent to take the polynomial in the top equal to 0. And the polynomial in the top, I copy no and the original way. I take advantage the factorization. I did this job. Then I know okay, each factor is equal to 0. 2x minus 5 is equal to 0. 2x equal 5 divided by 2. Both sides. X is 5 over 2. Oh, in decimal, 2.5. So we get 1 point, get 2.5, 2.5, comma, 0. Because remember in the procedure for finding x in a set, you suppose que y is 0. And we have another yes, of course, it's x plus 1 equal to 0. It's obvious que es negative 1. Negative 1. So actually, we have two intercepts. I like that because it's more information, more useful information. And so far, we have 1 point, 2 point, 3 point. Good. Okay, let's move on to the 4, que es obvio, always vertical ascending. And vertical ascending, remember the formula, you take the polynomial at the bottom equal to 0. Polynomial at the bottom is x squared plus 1, we are like is prime. The reason it's prime is clear, because we cannot factorization in the real field, because the solution of this equation is complex or imaginary. Okay, suppose that I didn't know anything, I don't remember that part. Why don't you try to do your best to solve this equation? It's incomplete quadratic equation, x equal plus or minus I. So you see that the value that you are looking for is imaginary or complex is because the vertical asymptote do not exist. Okay, we have no. This curve have no verticals. Do you understand this idea or no? Do you understand this idea or no? Okay, do you understand that do not exist a vertical asymptote? See if the polynomial in the bottom, the zero is complex or imaginary, is because we have no. Okay, what about horizontal? What's line? I have no idea. Well, I copy again our expression 2x squared minus 3x minus 5 divided by x squared plus 1. We are doing the for discover the horizontal asymptote or line asymptote. We are doing the analysis of the degree. Degree of the polynomial in the top is 2. Degree of the polynomial in the bottom is 2. Wow, I know very well by memory degree. Okay, when the degree is the same, yes, we have horizontal. No es not. Our value, this is not special, it's a regular case. Entonces now you take the leading coefficient in the top, que es 2, and the leading coefficient in the bottom, que es 1. Y equal 2 is our horizontal asymptote. A horizontal asymptote is a horizontal line. You are doing dotted line at y equal 2. I have no idea if our curve crosses or not the horizontal. So I need to investigate it, always. Okay. So you enforcing the situation. Look, this is part of the point 5. You take the original expression. And you enforce it to be equal to, because it's the value associated with the horizontal asymptote. Okay, if you solve this equation, you are doing your best in algebra. Maybe cross multiplication is useful. To write this equation in only one line. This is 2x squared minus 3x minus 5 times 1 stays the same. And now we have here 2 parentheses, x squared plus 1. You distribute it now. It's 2x squared plus 2. Wow, nice. That part is canceled out. And stay alive, only negative 3x minus 5 equal to minus 3x is equal 2 plus 5 is 7 divided by minus 3, because my goal is solve for x. The answer is x equal minus 7 over 3. This is the famous point in which our curve crosses the horizontal asymptote is at the point negative 7.3, 2, because it's obvious that the y value associated with the horizontal asymptote is 2. Look here. No calculation, only using common sense. And this is another important point. But so far, how many points you have in my hand? Well, we have 1, 2, 3, 4.
4.
Good. Yeah, super. We are good. Maybe if you need more points in order to visualize much better the curve, we plot different points. What about symmetry? It's important. You spend a few seconds to analyze symmetry, guys. This is no, and not necessary. You prove strictly. You only, for example, you copy 2x squared minus 3x minus 5 divided by x squared plus 1. And you mentally, we are doing reflection. And reflection means you replace x for negative x. You say, okay, let's do it. 2 negative x squared minus 3 negative x minus 5 divided by minus x squared plus 1. Okay, you know very well when the exponent is an even number, it stays the same. But here no, it's plus because double minus 3x minus 5 divided by x squared plus 1. Again, repetition, the same idea when you see it. And we compare this new expression and this is the original. Es obvio que no, it's not exactly the same. So no even, and it's completely opposite sign. No, because 2 is positive, 3 is positive, here 3 is negative, 5. Nor odd. Entonces neither. Fortunately, the positive value and the negative value have no relationship. I need to plot this. To selection the different point can help me to understand the curve. One more time, I am doing the ordinary number line. I plot the information that we have so far. One of the information that we have so far is, well, you have the y and z listed here in 0, -5. But unfortunately, we have no x and z. And yeah, it is x and z, yes. We have 2. Okay, it's here in 1, 2, 3, 2.5. This point is 2.5, 0, it's x and z. And also we have another here, -1, 0. Okay, entonces I have idea. Maybe you evaluate, for example, unfortunately nobody does it. Okay, no problem. You evaluate, for example, you evaluate 5. Okay, what is the reason I select 5? I have no idea. This is 1, this is 2, this is 3, this is 4, and this is 5. You can select 4, you can select 5, you can select 6. Select one value after this point. I select, no, I don't understand why. I select 5 to have some idea how it look like the curve in this region. I select also 1. 1 is important. Or 0 is important. No, 0 no. Well, 0 yes. Okay. 0 I did that. 1 because there's one total arbitrary point in between this x and z and this x and z. And finally, I evaluate -5. Here, over there, -5. And basically, I select minimum amount of point to selection is this. You say you evaluate g function, n1. Okay, I want to avoid that situation. This is just plugging in and verify and -3. Therefore, 1 point is 1,3. 1,3. G evaluate in 5. I did in my paper also. Is 1.15 positive. This is 5, 1.15. This is just plugging in into the original expression, no? And the rest is arithmetic. Using calculator. -3, -3, or -5. Oh, okay, I select no -5, sorry. I select -3, but it doesn't matter. This is -2, -3. Forget about this guy. I select -3, this is -3, the answer is 2.2 positive. And the point is -3, 2 point. I have a lot of points to plot that. You need more points to visualize. Well, no, you can. Okay, therefore I go directly to the source. Do you see this one?
Yes.
Okay, this is this example. Look, I plot that. Look at the behavior. Wow. Okay, I plot the famous point. Where's the famous point? Well, the famous point, I use in green color for the famous point. What is the famous point? The x and the z is -1 and 2.5, and the y and the z is 0.5. Okay, good. After that, I get another famous point. Is the point? Look, this is important. Do you see clear that there you go. That horizontal asymptote. Look, a flash in this. S at y equal 2, and the famous point in which our blue curve crosses the horizontals. Not always this equation happens. No, but sometimes yes, and you need to verify. Okay, entonces I select 3 arbitrary points and 5 and 1 and -3. Boom. We plot. We need to suppose that you don't see. Okay, with this information, for example, you don't see very well the curve. Okay, you plot more points. This is I explain what is the minimum, how you select the minimum point. Okay, all right. Any question on this problem? You see, it's important to be aware. Because sometimes that. Go ahead.
No questions.
No question. I try to explain. Sometimes, it's important that you are capable to see when we have no periodic acid. Okay, because the zero of the polynomial in the top and the bottom, sorry, is imaginary or complex. Okay, this is important concept. Okay, you need to be aware. Okay, do you see the whiteboard now?
Yes.
Yes or no? Yes. Okay, I want to erase everything. Wow, what the hell? Okay, delete. Okay, let's move on to example 3, no? Yes, for today, 3 example. Example 3 now. Good. Example 3 is a function. Its name is h, and the top we have polynomial degree 2, and the bottom we have another polynomial degree 1. Polynomial, binomial. Okay, polynomial is a particular example. Okay, so what is the step 1? Always. What is the step 1?
Factor.
Exactly. You're right, miss. Factor 4. Okay, so you take the polynomial, the trinomial, sorry, x 2x squared plus 9x plus 4, and you multiply that number. It's 8. I suppose the combination is 8 and 1 because 8 and 1 is 8. Somehow 8 plus 1 is 9. Okay, so you split our trinomial like a polynomial using not 9 anymore. You're using 8 and 1x plus 4. Now here, factorization by grouping. The great common factor in the first couple is 2x. So it's x plus 4. The great common factor in the second couple is nothing, and nothing is 1. X plus 4. I can see clear the x plus 4 factor is common. I factor out and stay inside this next parenthesis, get the last one, 2x plus 1. Okay, I did the factorization, the top part. Okay, unfortunately, the factorization on the bottom part is impossible because it's primary expression. I copy then. I copy x plus 4 times 2x plus 1 divided by x plus 3. When you have only one binomial, not necessary put the parentheses. No. You can if you want, but no. It's not necessary. Okay. I did the factory 4. Entonces, in this moment, wow. I see que it's there. Common factor que we can cancel out. No? No? Oh, yes. No, right? That's mean that we have no hole in our problem. Que es frequently happen, no holes. Sometimes yes, sometimes no. What is the second step? Help me.
It's in the set.
Y-intercept.
Very well. And this is easy. Evaluation 0. Evaluation 0 is 4/3. Look, it's easy. Look, mentally, in my mind, I delete mentally this guy. Look. This guy, I delete mental. Because when the x is 0, disappear the part contain x, no? And mentally, I delete mentally this x. And stay only alive 4 in the top, 3 at the bottom. Okay, 1.3 repeated. 1.3 repeated. And this. Entonces, our famous point is 0.1.3 repeated. They plot that. And decimal. I recommend decimal anytime. You are doing the paper, the test on paper, using decimal to do the graph. And you download the image and attach with the paper. Number 3 is excellence. Excellence is a little bit different. Because it's a function equal to 0, que es equivalent to say that the top part is 0. And the top part in our example is x plus 4, 2x plus 1 equal to 0. Therefore, x is equal to -4. And the second is 2x plus 1 equal to 0. So 2x is equal to -1 divided by 2. X is equal to -1. Conclusion. We discovered two excellent sets. Que es the point -4,0 and -1/2, 0. Yes, we are right. I want to erase that part because this is important information that we have. So far, we have 3 points. 1, 2, and 3 points. Good. I like that. Number 4 step is compute the vertical asymptote. What is the formula? Well, the formula is cube x equal to 0. So you take the polynomial, yes, in the bottom, this guy. In our example, is x plus 3 equal to 0. This conclusion is x equal -3. This is our vertical asymptote. Good. Now, the most complicated part is now number 5 step, que es determine horizontal or slant. What do you think about that? Come on, opinion, any opinion? Any opinions? What is the analysis?
Horizontal. Because is the degree is equal.
Okay, let me copy again. 2x squared plus 9x plus 4 divided by x plus 3. Remember the analysis of the degree. The degree of the polynomial in the top is 2. And the degree of the polynomial at the bottom is 1. Wow! And when the degree in the top is bigger than 1, the degree of the denominator, what kind of asymptote we have? What kind? What kind, miss?
Slant.
What do you say?
Slant.
Exactly. We have no horizontal. No. Boom. We have a slant. And this, I repeat, this only occurs when the degree of the polynomial in the top is bigger than 1. No 2, no 3, no 4, only 1. The degree of the polynomial and the denominator. Okay.
I have a question, Professor.
Go ahead. Go ahead,
So
go ahead. Go ahead.
so because like you will factor the equation. So
Uh-huh.
I thought like we look at the second one, not when we ask the horizontal or slant. The second one we should, so when you asking about horizontal or slant, we should look at the first equation, the original, not the second one, right?
Yeah. But
I
that's the
wasn't
same,
sure.
miss. But that's the same, miss. It's the same. Look, let me explain in another way. Look, it's the same. Good conclusion. You are doing good conclusion. However, see you take the factor 4, you see the same picture. Because when you apply foil, pero aumenta foil, you want to investigate degree. Degree multiply this and this is 2x squared. Yeah, I don't care the rest. The rest is garbage. It's useless. And the bottom, you have x. And the 3 is garbage. Useless. This is information. Degree 2, degree 1. Same analysis. Got it?
Yes, thank you.
No problem. Okay, what do you think about symmetry? It's 6, example, 6 point. Symmetry. Remember, symmetry is super easy. You spend few seconds to discover the symmetry, and you mentally replace x for negative x. And our original expression is 2 minus x squared plus 9 times x minus x, plus 4 divided by minus x plus 3. Well, in the top, for example, this guy stays saying there's 2x squared. The reason is clear because the exponent is 2. But in this case, no, change. In this case, stay the same 4. But in this case, change. And it's completely different to the original. There are no possibility of the symmetry. No symmetry, therefore our function is neither. If neither, don't worry. Be happy. Because the only complication is that you cannot take advantage that the positive value and the negative value have not necessarily exactly the same value or opposite value. This is even, this is odd, now it's neither. This is neither, this value positive, suppose 3, and this value negative 3. There are no connection, there are no relationship. Okay, no problem. Let me now verification. I forgot something. Hello, I forgot something. I forgot inside the topic 5, the point 5, I forgot to check if my function cross or not the horizontal. And remember, the horizontal is located at no. See, this is line. Sorry. Okay, we're doing right. It's my bad, my mistake. This is line. And line, you can cross it. You can, but also it's very weird happening. No. Okay. Now the rest is just plugging in arbitrary value. Okay, to save time. Well, okay, I pick in my paper. This is number 7. I pick completely arbitrary, guys. Suppose I evaluate the function. The name of the function is no f, it's g, it's h. So h evaluate in -5. The answer is -4.5. Therefore, we have in my hand 1 point is the point -5, 4.5. You only h in -2, okay, is -6, the answer. So it's -2, -6. And you evaluate in 1. At least 3 is enough. The answer is -3.75. Entonces es 1, -3.75. Wow, with this information, we have enough information to do a decent graph. Because you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 point, good. We have one vertical asymptote and -3, and we have one slang. But I forgot the slang equation. Hello, I am crazy. Look, the slang equation. Continuation of this. I forgot something, no? The slang equation you obtain after the long division. Wow, I forgot this important moment. But okay, let's do it now. You divide this polynomial, is 2x squared plus 9x plus 4 divided by x plus 3. Okay, let's do it. It's a 2x. So by 2x, because when you multiply 2x times x is 2x squared. By subtracting, change the sign. And this is 6x positive, but by subtracting, change the sign. Is it cancelled? 3x. Finally, bring down 4. We don't finish, of course. You finish when the degree of the remainder is smaller than the degree of the divisor. We need to continue. So plus something, plus 3. 3 times x is 3x. Subtracting, change the sign. And 3 times 3 is 9. Positive, subtracting, change the sign. And -5. Stop here. Now I know that our expression is given at the beginning is 2x squared plus 9x plus 4 divided by x plus 3 is equal the remainder is 2x plus 3. By the way, this is a slang asymptote equation. Minus 5 divided by divisor, que es x. For a moment, this information is not important. Well, it's important to see that we have vertical asymptote, but we determined before vertical asymptote at x equal -3. Okay? Everything together in decimals. Everything together in decimals. You relax, you go down, you open decimals, okay, and you put everything, and you are super smart, and you put the original equation also, no? And let's see something like that. Look. Okay. Look like we are, no? But it's idea. Okay, you put equation, look, in green color. I plot auxiliary thing, is the vertical asymptote at -3, look. And the equation also of the slang asymptote is 2x plus 3. And you can see how our graphic approaches to this asymptote, but I guarantee you can never touch. Okay, this is the idea for it. Never touch. Let me make it zoom here. You see approach, but never touch. No, it's not exactly parallel. The distance is smaller, but never finish. Okay, so let me make a zoom. You click, when you make a zoom, and you want to focus in the center area, you press zoom, predetermined. Wow. So I can see the famous x in a set. It is -1/2,0, -4,0, and our y in a second is 0,4/3, que es 1.333. I plot the point in 1. This is the additional point 1, and -2, and -5. And you have some idea how it looks like the curve. Okay, you know this a little bit long procedure, but this is not the problem. You are doing step by step. I send the test on paper with anticipation, and you have time to do everything good. Any question on the test? No, because I cannot help. Well, in the homework, you are doing the homework online. I can. Yeah. Okay. Moving on to the whiteboard. No more graphic of this, too much. Let's spend the rest of the time doing one more topic in the chapter 3. In the chapter 3, in the chapter 3, we study now one new topic. It's called polynomial and rational inequality. Another book called nonlinear inequality. Let me present the idea. Okay. Now basically, we are studying now polynomial and rational inequality. Es sinónimo, non-linear inequality. Okay. Let me explain in detail the procedure for solving nonlinear because it's completely different. I think we are doing in chapter 1. In chapter 1, well, okay, you're solving compound inequality, but you're solving always linear. Now it's non-linear. Okay, let me start for the one example and illustrate the technique to do everything, because I would like that you are doing exactly the same I'm doing. Another professor explained different, like me. Well, as I said, any smart and true way to solve that. However, this procedure that I want to explain right now is a combination of a little bit algebra plus one graphic part. In the test, I want to see both. So not only you solving this inequality using algebra. No. You're using algebra in the first part, and after you plot something I want to explain now, and finally we finish one table. Okay, summarize everything in one object. Suppose this inequality: x cubed plus 2x squared minus 3x greater than 0. Okay, super. The first thing you should do, so my inequality contain always left-hand side and right-hand side. And right-hand side. And mandatory, guys, right-hand side must be 0. In this case, actually, it is 0. Nice, I appreciate so much your help because I don't need. But another problem you see before, no. So you need to, and you understand why. It's the reason it should be 0. Or must be mandatory 0. Okay, so we focusing on the left-hand side. And you factorization this triangle. Es obvio que the great common factor is x. Okay, factor out. X squared plus 2x minus 3. Greater than 0. I finish. No, we have trinomial factorization. In this case, super easy because it's regular. You open automatically 2 parentheses. And then a combination, open the door, is 3 and 1. Because 3 times 1 is 3, and 3 minus 1 somehow is 2. The signs are positive 3 and negative 1. Wow! Because in this crucial moment, I enclose in the box this new inequality. By the way, is equivalent to the region. Some problem more complicated, guys, but after I will will explain after. The inequality can enclosed in the box is equivalent to the original, but it's look like completely different. In this case, no, because we are doing not too much. We are doing factorization, factor complete, and that's it, GCF and trinomial. But in other, no, another you need to apply least common denominator to say that you transform it and you get completely no it's different the word. The is equivalent, but in the shape it's completely different. Okay. So we start now. This is the first step, factorization. We start now. To start now, you find one important thing que es called critical value. Critical value. And critical value is not the solution. Critical value is the points que help me to solve the inequality. How you find that? Well, easy. You copy again our original inequality, but not like the equality, like an equation, not like an inequality, no equation. You replace, doesn't matter if greater than or less than, you replace by equal to find critical value, to find CB, critical value. Okay. Entonces now, what is easy? You have 1, 2, 3 factor, makes sense because my original polynomial is degree 3. Then we have 3 solutions. The first solution is x equals 0, que es this factor, equal to 0. The second is x plus 3 equal to 0. Obviously, it's negative 3, is this factor. And the last factor is x minus 1 equals 0, is x equal positive 1. In total, we have 3 critical values. Critical value in our problem is x equals 0, x equal minus 3, x equal positive 1. Okay? Everyone follow me so far? We don't finish. We are in the middle of the process. What's the next step? The next step is graphic. I finished only the algebra. In the graphic, well, you are doing the all real number line. Easy. I want to see in the test this idea. 0 here in the middle. And 0 is critical value. So you put a dotted line, similar to the idea for the vertical acid. But no, actually it's another thing. It's just partition. And negative 3, 1, 2, 3, another partition. And 1 here, another partition. What is the idea? The idea is that this all real number line, you using the critical value, you did 3 partitions. Therefore, we have 3 intervals. We have the interval, the interval, the interval, and the interval. Actually, 3 partitions represent 4 intervals. And you pick 4 testing point. Testing point selection, testing point. When you select arbitrary inside each interval, suppose I select -4. Suppose I select here -1 or -2 or negative whatever inside this. Suppose I select this and between 0 and 1, I suppose I select 1/2, positive 1/2. And after 1, I select. This is our testing point. And the testing point, you can plug it in one by one in the original inequality and verification. See the statement is true or false. However, I propose you one, like a mnemonic divide technique is using one table. The table is super easy. Look, the table, you create one column here for the testing point, TP. I call TP, testing point, and you listing vertical, the testing point, -4, and create one row. -1, I create this next row. 1/2. I create next row, and 2, I finish the table. Okay. Now we have different column, no? And the column represent the factors involved in my problem. Look, I come back to this famous expression. The factor involved in my problem is x. I copy that. X plus 3. I copy that. And x minus 1. I copy that. And you attach one additional column that I call total. And inside the total, you summarize everything in one column. Like when you finish the table, this is the important column, the total. It gives me the information on what testing point passed the test or failed the test. But it's easy, super easy. Look. I don't care the value. I care only the signs. Okay, so positive or negative. So you plug in -4. This is -4. You plug in any expression. Here, and here. Let's do it. Look. Okay. -4. It's obvious it's negative. Yeah, I put negative. There's -4. -4 mentally. -4 plus 3 is -1. Do you see that? Entonces you put negative. And -4 and -1 is -5. It's negative. We have 3 negative. And remember, the total signs is obtained under the multiplication. You have 3 factors. Remember, factor. Negative is obvious that the total sign is negative. Because negative times negative is positive. And positive times negative again is negative. Entonces, wow, okay. I put negative and closing the circle because it's the column important. However, what is the rule, professor? So you have even number of negatives. Suppose you have 2 negative and 1 positive. It's obvious it's positive, no? Because we have 2 even number of negatives. See, we have, in another hypothetical example, we have 1 negative. 1 negative. Suppose we have 1 negative. Multiplication by positive. It's obvious it's negative, right? You have negative times positive. It's obvious it's positive. Makes sense, right? Let's continue. Entonces now -1 is negative. -1 here is positive. Because it's -1 plus 3 is positive 2, no? And -1 and -1 is -2. 2 negative is positive. 1/2 is positive. 1/2 is positive. 1/2 is negative. We have negative here. 2 is positive. 2 is positive. And 2 is positive. And we finish the table. Now the most important moment. No, it's the most important moment. The most important moment is when you write the final answer. No? Okay, the most important moment is, look, I come back at the beginning, at the original inequality. This one. And the original inequality, in the right-hand side, we have greater than 0. And this is equivalent to say, okay, our expression is positive. So it's equivalent to say, okay, this is positive. But the only testing point can give me positive sign is this and this. This is past the test. This is true. And the other no. The other is false. Fail. So the only testing point to pass the test was the testing point -1. So this interval solution. And 2, get this interval solution. Be careful, because 2 is only testing. But my interval is extending from 1 to infinity. My interval, my second interval, okay, is the solution, is extending from -3 to 0. And what about the endpoint? Let me see the endpoint. The endpoint is parentheses, parentheses, and parentheses. How do you know that? Because my inequality, look, is a strict inequality. Do not contain equal sign. No. It's a strict inequality, no equation. Therefore, the endpoint is not included inside the solution. So what is my final answer? My final answer is, copy that, final answer. Final answer. Well, is using two interval. Is from -3 to 0 union. You connecting this piece and this piece together by the union to say from 1 to 3. Boom, final answer. Super good. Okay. Too long, I know. But let me try to summarize. Step number 1. Try to guarantee the right-hand side is 0. Factorization or no necessary factorization using algebra. Yeah, factorization using algebra, el least common denominator and the rational. And you determine one compact inequality in which the right-hand side is 0 and formed by different factors. After that, you convert temporarily to equation because I want to find the critical value. The critical value is the value in which the polynomial is 0. Now, ese moment que I suppose, hypothetically, I suppose, que change the sign. Okay. Some students prefer doing it that way. Look, now one visualize. You put negative here, this negative is this. Positive here, negative here, and positive here. And no create the table. Okay, it's good. That's good. I explain my way. Maybe you see before this in another way, but if you apply a logical idea, I grade correct. Okay. Now the critical value helped me to make a partition because I suppose that the polynomial is something like that. Look, negative, positive, negative, positive, something like that. It's a graph of the polynomial. I suppose. I can do it this one. No? Okay, now you pick arbitrary testing point. You will create a table. The table is easy. One first column gets the testing point. And we have several columns that depend on the factor that you have in mind. And you plug it in easy because it's linear. Not necessarily plugging in the horrible original expression of the power 3, that maybe you make an arithmetic mistake, no? You plug it in easily and one linear. Plugging in x, plugging in x plus 3, and plugging in x minus 3. And you determine individual designs and using the rules. You have an even number of negative. Okay, it's important to say something now. It's important to say that the guys que control the sign, the total sign is the negative. The positive, no. The positive participate in the game, but weak. Now, strong participation is the negative. So you have 3 negative and negative. So you have 5 negative and negative. So odd number of negative is negative. Even number of negative is positive. 2 negative, positive. 4 negative, positive. 6 negative, positive. In another more complicated example, you know? Super. Any question? It's clear or confused? Very confusing. It's clear? Nicole say it's clear. But Nicole, I promise they want to complicate a little bit more. Remember, my first example is easier. It's always kindergarten example to motivation. After I want to complicate more, with different version, different options you can find. Okay, look. Suppose example 2. We are doing, guys, polynomial and rational inequality. Example 2. In this case, I complicate. I put x to the 4th power greater than or equal 4x squared. Solve this. Well, I have no idea what the hell is that. I am totally lost. But I remember something. The professor said they need to manipulate algebraically in order to guarantee that the right-hand side must be 0 always, anytime. Okay, therefore I move 4x squared to the left. Super good. This is important. It's impossible to do something without this condition. Okay, right-hand side must be 0. To understand much better. Why is the reason? Well, the reason is clear. Because 0 level is the comparison level, and you determine si it's positive or negative. Suppose que 0 represents the level of the C, and you want to see if it's under or over the level of the C. But this is important because the table is basically foundation only the consideration positive negative, positive negative. But positive negative will respect the what? It's obvious that we respect the 0. Okay, there is a reason que no accept any manipulation until you don't guarantee this condition. Super important. Well, the recipe is okay. It's elementary algebra, factorization. The great common factor is x squared. A factor of x squared, we have x squared minus 4. Write it down, we go to 0. I think no, because I saw the differences of a square. Here, look. So I break it down to parentheses. Square root 4 is 2 plus or minus. Oh, nice. And this is our, look, new inequality, que by the way, is equivalent to the horrible inequality that nobody understands. Okay, but this is equivalent 100%. This represents the same thing. However, this is easy to manipulate. What is the next step? Well, the next step is the critical value. And the critical value is easy because I put it like equation. Temporary is supposed to be 0. And by the way, this problem we are solving now is no strict inequality. It's no strict inequality because contain greater than or equal. It's inequality and also equation. This is equivalent to say greater than is a strict inequality or equal. That means that the solution for the inequality, when you find graphically, and the solution for the equation is a point, together is the solution of the our problem. This situation happens because it's non-strict inequality. It's greater than or equal. Si es greater than only, bueno, entonces you solve the inequality only, using a similar idea that we're doing in the first example. You understand the idea? Inequality and equation. We are solving now together. That means that the critical value belongs to the solution. Okay, no problem. So say x squared equals 0. No problem, I understand. Square root both sides. X equals 0. X plus 2 equals 0. X is minus 2. Good. And x minus 2 equals 0. X is positive. Oh, wow, this is our critical value. Using the critical value, you are doing the partition of the all real number line. Partition of the all real number line. positive infinity, negative infinity. Okay, 0 partition. -2 partition. And +2 partition. 3 partition. 4 interval. This one, this one, this one, and this one. 4 interval. And you pick totally arbitrary testing point inside each interval. For example, I pick in my paper -3. I pick in my paper -1. I pick in my paper +1. I pick in my paper +3. But suppose another student pick +4. 5 is the same because 3, 4, 5 have the same behavior. That when you plug it in the table, so you plug in 3 or 4 or 5, it's the same true or false. So because belong to the same interval. Well, okay, entonces my recommendation is select close, near to the partition. Okay, let's do our famous table. Let's do our famous table. Remember, the organization for the table is one first column, okay, listing the testing point. Testing point are -3. Oof, no good. -1. +1. And +3. And the factor in our problem is x squared, x plus 2, x minus 2. And don't forget the extra column tested one. Okay. This is the idea. I don't know if I can erase or not. Erase that part. No. No. Yeah, let me see erase or not. No, it's okay. Okay, so now remember, plug it in, -3, oh, -3 squared. And 9 positive. Okay, entonces -3 plus 2 es -1. Es negative. -3 and -2 or es -5. Es negative. And 2 negative is positive. -1 square. Look here. Push. What are you doing? -1. -1 square is 1 positive. Oh, by the way, I something I saw. That column, okay, the column of the x squared, always should be positive, regardless if the value you plug in is negative or positive. Why, Professor? Because it's a square. And square is always positive. And you say another thing, Professor. You say that the positive sign in the table don't control the total sign, only control the negative. So what is the reason to copy this column? See, always is positive. Good. So when you see exponent even, you totally mentally delete. This is not participating. It's one important shortcut. Okay, I want to explain in detail next time. But at least I want to put this example to introduce this new idea. O sea, the new idea is you have several. Look, you have one hypothetical example, complicated example. We're doing the factorization, 1, 2, 3, 4, and the exponent here is 2, the exponent is 3, the exponent is 4, and the exponent is 5. the factor that contains exponent even, you can delete. And you simplify your equation. You copy only into the cubic and fifth power. And you working in this direction. Okay, and the reason is clear. Because when you raise to the even exponent, the answer is positive, no? So have no sense to take, and you simplify your table, and you simplify. Of course, in the real life, I see at the beginning this, because I do not consider it never this factor. But I consider this, by the way, the exponent 1 invisible, of course, and this the exponent 1 invisible. When I create the table, I create it without this column, because I know this fact. Okay. Negative 1 is positive. So negative 1 plus 2, and negative 1 is negative. So it's negative. Okay, I enclose the total sign. It's important. I don't care the rest. Important is this column. And 1 is positive, and 1 is negative, and negative. And 3 is positive. And 3 is positive. Okay, I finished the table. Good. Now, after that, I come back to the beginning. The beginning say my inequality is greater than or equal to 0. And si es less than, is another. Let's see another example. Is less than. It depends on the information is given. This is a synonym to say positive. Okay, so therefore, the solution is supposed to be this and this, the positive, and this no. You don't need to cross. No, you leave it like that. So the important for me is the point que pass, not the point que fail. So I put the check mark in the positive in this case. So in this case, I suppose that this corresponds with the negative 3, is this interval. And positive 3 is this interval. And the rest no. Okay, super. And what about the endpoint? Oh no, I have no idea. Yes, no, I have idea. Look, the endpoint belong or no to the solution. Let me see. Let me try to understand this. Select yellow. Okay. Remember, equal sign is the solution for the equation. Okay, 0, negative 2, and positive 2. Okay, let me make a zoom to see more clear this thing. Look, I can see that negative 2 belong to the solution. I put a square bracket here. Positive 2 belong to the solution. I put another, no parenthesis, square bracket. That means it contains this. And 0 also a solution. And 0 represents like a one isolated point in the middle of the all real number line. Okay, this is what my final answer. My final answer is final answer. Well, it's from negative infinity, comma, negative 2, bracket, important that bracket, union. Entonces, the orden is not important. You copy, pero I like a copy from left to right. So when you go from left to right, writing the inequality, I see this in the bar, I see 0, but 0 represents one isolated point. And normally they have it to represent one point. When you solve the equation, remember you say solution set, suppose que es 1, 2, 3, you separate by comma 1, 2, 3, the solution. This is the correct way, the traditional way to express the answer for the equation. Because 1, 2, 3 represent points, no interval. Interval notation is when you want to represent a bunch of values. Interval. Okay, so now I have union also, union. union, and the last interval is bracket 2, comma infinity. This is the final answer. Any question? 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 Come on, question.
No, professor.
Okay, super. Okay, okay. Entonces, I want to finish. Well, I want to decay only 8 minutes. I want to finish not 40, you know, 30, 35, because I need to go to one place. But it's okay, we continue. Okay, now I want to explain in detail the idea of the, it was not clear, Professor, when you delete or when you don't delete. Much better now. Okay, look. I want to explain much better now. Suppose this elementary example. Elementary example in which you have, for example, parenthesis x minus 5, x minus 4, squared. Suppose que es given this inequality in the test. Entonces you need to be aware the situation of the simplification. Sometimes when you simplify something, you obtain one easier inequality, and we cannot, or we don't need to make partition table, not too long process, no, because you detect it immediately. Wow, this factor is raised to the even exponent, and you totally delete, mentally. Yeah, I know very well that this equation is equivalent to x minus 5 greater than or equal to 0. Wow, amazing. And this is an equality that we are doing in the first chapter. Is solve for x greater than or equal to 5. And always you express this answer in interval notation. In the test, never leave it like that. No, please. You express it in interval notation. Okay, suppose que you, to see much better, you are doing auxiliary drawing, o sea, a sketch of the whole real number line. This is 0, 1, 2, 3, 4, 5. In what direction? Well, it's greater than the direction. Include the 5 inside, yes, because it's equal, it's a bracket. Conclusion, my final answer is bracket 5, comma infinity. And interval. This is my final answer. Okay? However, no, it's too easy. No. Suppose that you copy exactly the same problem, but you omit one small detail. I omit in the test intentionally. I put greater than 0, no equal. Entonces you say, professor, it's easy. I saw que this is even, nice, no problem. Now I delete. No. O sea, when you have equal, you can totally delete. And when you have no equal here, you don't have equals here. You delete, but partial delete. Let me explain this again. Partial delete. Why partial delete? Because you solve that problem. For example, in this case, no. Okay, in this case, no. In this case, no. Another is more interesting. Look. Forget about this for a moment. One more interesting. Okay, it's similar, no? But change one number, of course, you see much better than it. Suppose we have x minus 3 times x minus 4. Okay, square. X greater. Okay, be careful. Because what is the difference? The difference is that we have no equal. So you see no equal and you see even exponent. Wow, so you partial delete. What means partial delete? And what is the reason that you don't delete totally or completely? Well, the reason is, well, you take x minus 3 greater than 0, similar to this. You solve this is 3. When you are doing a representation, this is 0, 1, 2, 3. I know that the interval, our interval is from 3 to infinity. But now include, of course, 3. And the symbolic way to indicate this idea is parentheses. And this answer is wrong. Why is wrong? Because include 4. Look. And let's see what happened with the 4. Well, suppose that you are doing it this way. This is wrong. Why? Because 4 is inside the interval. And 4 do not satisfy this interval. Why not? Because when you plug in 4 minus 3, 4 minus 4 is squared is greater than 0. 4 minus 3 is 1. 4 minus 4 is 0. 0 squared is 0. So says 1 times 0 is greater than 0. 0 is greater than 0. And you get the contradiction. Wow. You say, how can I solve the problem? Again, using table? No. You apply partial delete. What means partial delete? Well, I want to explain now. You have this equation. You want to copy the origin again. You realize a partial delete. Why partial delete? Because you contain one factor que have even exponent. This give me a clue que es delete, pero partial o total, two categories. Es partial because we have no equal here. Si es equal, totally delete. No problema. Pero when there's no equal, no. But this is equivalent, this statement, let me write here. It's equivalent to say x minus 3 greater than 0. Exactly like that. We're doing so far well. Pero and x no 0. No 4, sorry. It's the whole. It's the whole. Actually, in 4 we have a whole. Okay. Now this is the meaning partial delete. Okay, look, this is the formula. Okay, you partial delete. Okay, you delete this, pero partially. You include like a whole here. Entonces, professor, what is the final answer? Well, the final answer is exactly the same of this, but we exclude the whole. So we have parenthesis 3,4 close the parenthesis union 4,5. Boom! Final answer. Okay, guys, we continue Friday, of course. I want to do more examples of this. And the last part is super easy. Friday, I sent to you the review package. Maybe Friday we start review and we continue Monday. Okay, super good, no problem.